Welcome everyone to the talk on RTC observability. I'm Ishan. I'm a software engineering manager supporting the observability team at Meta. And I also have with me my colleague Mandeep Deol, who is a software engineer on the same team. Together, we are going to talk on RTC observability. What is this area all about? What are the various challenges in it? What are the novel solutions that we came up with? And the future scope that lies ahead. So before we begin, let me answer the simple question, what does observability even mean? Well, simply put, observability is a measure of how well you understand the underlying system. Now here at Meta, we like to divide this area into various themes that help us to prioritize and organize efforts in each of those themes. So the first theme is platformization. RTC at Meta is not just a service for one product, but a platform that serves many different products. So, platformization helps us make sure that we build generic solutions that scale across all the wide variety of products that RTC support and work in various different conditions, such as low bandwidth or constrained devices, as well as high end enterprise scenarios. The second theme is privacy. Privacy is at the core of every product that we build at Meta. Whenever we upload any user data, we always need to make sure that it does not violate any user expectations. At the same time, any engineer that accesses that data only does so with the proper business need and in order to improve our products. That is what we tackle in the theme for privacy. Now, there are two more themes, reliability and efficiency, that are very closely tied to each other. Reliability makes sure that all logs that are uploaded are reliably uploaded and are present wherever engineers expect them to be. Whereas in efficiency, we make sure that we get maximum value out of any log we upload. This is because any log we upload has a cost associated with it. In terms of the client CPU that it takes to compute this log, the client bandwidth that is needed to upload this, which can also interfere with the calling performance. But even on the server side, there are costs related to storage and CPU. So there's a very tricky balance to strike between reliability and efficiency. And the final and most challenging theme around observability is call debugging. This is where we dive deep into particular calls and try to analyze them. So this is the focus of our talk, and we'll talk in more detail around the challenges in call debugging, the novel solutions that we came up in this space, particularly related to real-time log aggregation, and the future scope in observability area. Now, as we talk about call debugging, all of us always had that one instance of a bug that was really hard to repro, and we couldn't even understand how the system got into this place. So that is the challenge in call debugging. But there are broadly two major challenges. One use case is when we want to analyze a lot of calls in aggregate. This is really useful for analyzing trends or reacting to user behavior. There are a lot of proprietary tools already existing that are able to effectively solve this problem by building tables that log all of the data related to a call and then creating visualizations around them. However, there is another big challenge in call debugging, and this is when we need to dive deep into a particular call to analyze all of its data in detail and find out some edge case scenario or issue that is really hard to debug. So for this particular challenge, we built a proprietary tool called Call Dive. And as the name suggests, it enables you to dive deep into a particular call. This collects data from all the participants in that call and provides a lot of visualization tools depending on the structure of the logs that we collect. Each log has a different structure. Some are better visualized as a time series format, whereas some are better visualized as histograms or bar charts. And this is what Call Dive enables us to do. It allows us to slice and dice the data in order to quickly find where the problem might be and fix it. This is a tool that is loved by all engineers across Meta. However, you might be thinking, how did we come up with this tool? and what are all the challenges that we faced along the way. And most importantly, is this really the most optimal solution that allows us to effectively scale call debugging to all our products? And how do we uplevel the observability area from here? So to talk about all of the challenges and how we came up with this tool, I'll pass it off to my colleague Mandeep, who will dive deep into the technical challenges.
Thanks, Ishan, for that wonderful introduction. I'm Mandeep Deol, and we're going to explore the call debugging space a bit more here, look at all the challenges we encountered while developing this tooling. So, let's get into it. All of the tooling that we have here at Meta in this particular space is backed by our common logging infrastructure. So let's look at that and understand that better to get a feel for the initial challenges that we had. All of the clients and the servers on a particular call are generating different types of logs, and all of these logs first make their way to Scribe, which is our distributed event streaming system. And from there, they can be streamed into different backends depending on the use case. So for example, they can go into our backends for our real-time data analysis tools that enable, trends analysis that Ishan talked about. Or they can go into Hive, which is our data warehouse, and from there they can be read by tools like CallDive, or at least the initial version of CallDive. I should also point out here that there's a one-to-one mapping between a log and a table. A log entry is a row in one of these backend tables, and a field is a column. So this is the initial sort of common infrastructure. Let's now look at what the challenges were here. So before I even get into like the problems with the initial version of CallDive or some of our real-time data analysis tools, I should mention that before any of this existed, engineers were just using Hive, the data warehouse. So in order to debug a particular call, they would have to make, dozens of SQL queries, fetch the data for individual logs, and then piece it all together themselves. And they had no support for any custom visualizations, like for any specialized data that we had. So that's sort of where the idea of CallDive came in, and some bright engineer put together a tool which can read all the logs for you without having to write any SQL. You can click on it, get special visualizations. But that initial version still had some problems. One of the problems was that the log availability delay. So logs can take hours to land in Hive because Hive is not designed for this particular use case. So engineers would, after an issue was reported, engineers would have to wait hours before they can actually start debugging and deep diving into that issue. Additionally, a single request to fetch one of these logs from Hive can have like a P90 latency in order of minutes. And so when you're making dozens of these requests to do the initial page load, you're almost certain to hit one of these, the P90 latencies, and have the page load take over like a minute. So that was a really frustrating thing for our engineers to deal with as well. And some of the real-time data analysis tooling that we have has the limitation that they don't support joins. So if you wanted to do any type of analysis that between multiple tables or multiple log types, you're kind of out of luck there. So those are the problems. Like what did we do about these things? So the first thing we noticed was that the key issue here in both of these domains was the segregation of logs. And this is an inherent problem in this space. It's sort of the nature of RTC systems. They're distributed. So what we decided to do is build a system called RAlligator, short for real-time log aggregation, to resolve these issues. Let's take a look at how RAlligator works and where it fits in. This is a high-level view of RAlligator. So of course, we didn't want to go and change all of the existing infrastructure, and we wanted to leverage whatever common infrastructure we had as much as possible. So RAlligator fits in right behind Scribe. So it's just another consumer, and it can read data from Scribe, and it can generate aggregated outputs for both CallDive and our real-time data analysis tooling. So what do I mean by aggregated output? For the real-time data analysis tooling, the aggregated output is just another new log. And it's a concatenation of all the input logs that we have, the separate segregated logs we have. And all of the fields in those become fields in this new log. In addition to this, we also have facilities for being able to add some custom fields. So you can write some logic and compute some values and add additional fields here as well. And that gets written out to Scribe and can be processed by our real-time data analysis tooling. So effectively performing a join. For call dive, we take the list of all the logs belonging to a call and write it in a single file to Manifold, our cloud storage system, and call dive can fetch it from there with just one request. Now let's sort of go dive a little bit deeper into the RAlligator architecture. RAlligator could be thought of as having 4 different components, or being made up of 4 different components. The first is Scribe Manager, which is responsible for managing, reading all of the data from all of the different loggers into the system. And then we have a call index, which is an in-memory key value store, where the keys are the call identifiers and the values are a list of all the logs belonging to that particular call. Then, of course, we have the metrics component, which is responsible for generating the aggregated log output and computing any custom fields that we want to compute. In addition to that, we have call completion, and this component is responsible for determining when enough logs or when all of the logs for a particular call have arrived so that the call can be processed. Another way of thinking about the system is that there are 2 sides to it. There's an input side and there's an output side. The input side is basically pulling data from Scribe and putting it into the call index. And then we have the output side, which is running on a timer. So the call completion logic is running on a timer and trying to determine, hey, like which calls have now received all of the data, and then writing out the aggregated outputs. Most of the components are fairly straightforward and simple to understand. One of the big challenges here is call completion. So you may have noticed that we're keeping all of the data for all of the ongoing calls that are in process in memory. So if the input rate ever exceeds the output rate for any significant amount of time, we risk running out of memory. This is why call completion is very, very important. And it has an incentive to try to complete calls as quickly as possible. So, we can complete calls and flush out the data from memory as soon as possible. But this is in conflict with our other requirement. We want the aggregated outputs to be as complete as possible. So if for some reason, if we complete calls too quickly, we risk not getting all of the logs for a particular call. And there's actually no deterministic way of knowing when all of the logs for a call have arrived. In particular, this is mainly due to reliability, in particular, like client-side logging reliability. Client-side logging, it has to play nice with the apps it lives in. There are certain restrictions for when logs can be uploaded, if at all. There are like bandwidth restrictions on, at which time on which networks, under which network conditions the logs can be uploaded. So this call completion is mainly a heuristic, and it works based off of server-side logging, which is reliable. So we wait for the end call server-side log, and then we have certain timeouts to wait for client-side logging. And if we exceed certain timeouts, we just flush the call at that time. These timeouts are based on like measure latencies that we have captured in production. This is very challenging and slightly tricky to get right, but we've managed to get it right, and it works fairly well in practice. Some of the additional design notes on RAlligator, of course, we're dealing with tons of data. We're processing millions of calls a day. We can't run on a single machine. So sharding is involved. Managing multiple machines is a challenge. Running the system across multiple machines is a challenge. And getting the write and the read side to agree on a sharding strategy can be complicated. In addition, currently we don't do any sort of replication or backfill in the system because mainly we're concerned about debugging use cases. And there hasn't been a real need to do this, but the data is available in Scribe for multiple days, so we can build a backfilling solution cost effectively if necessary. Many of the times when we describe the design of RAlligator, the question we get asked is, hey, why not use an external distributed key value store, something like Amazon's DynamoDB? The simple reason there is that it's not cost effective just because of the amount of data we're dealing with, and it has its own sort of replication cost related to it. So when we did our initial estimates, this cost was like almost an order of magnitude. So with that, you're up to date with the current state of things in this particular space. And now I'm going to hand it off to Ishan to talk about some of the future innovations that we're looking at.
Thank you so much, Mandeep, for that great technical overview on call dive and how we deal with call debugging. Now that we know all about that, let's think about the future. Where do we take it from here, and where are there more opportunities in like the whole observability space? So we already saw how amazing a tool call dive is, but that is barely scratching the surface of it. There's much more we can do there. We not only can add more custom visualizations for all of the different types of logs, but we are also starting to ingest more and more product logs into call dive, and each logs from every different product has its own structure and visualization. This is starting to evolve call dive as a platform to serve more and more use cases. On top of that, we are also starting to enable real-time debugging in call dive. Today, all of the logs are uploaded when the call ends. However, logs can be continuously streamed and visualized. This enables us to debug a call live while it is ongoing, and we can even fix problems and improve the quality of the call on the fly. Now, apart from just call debugging, there's various amounts of challenges in scalability. Video calling is now evolving beyond traditional audio and video to also serve other scenarios such as metaverse. These scenarios are much more complex and lead to a lot of logs being generated. This makes it very difficult to analyze all of these logs and also to handle them through memory constraint that we have within systems such as like RAlligator. So that is another challenge, and calling is also becoming more private. And we want to give users full control over the data that they upload and how it gets used and processed. So this is another big challenge in the privacy area. Finally, now let me talk about what's on top of all of our minds, and which is artificial intelligence. There has been so much advancement in this field, and we believe that observability is the perfect space where we can use all of these techniques. We already know that RAlligator is capable of producing metrics that power top lines for RTC. On top of it, we can even introduce metrics based off of machine learning models that can quickly classify calls with certain problems such as no audio issues or no video issues. This can help us quickly stay on top of these problems and fix all of these issues, and also capture user sentiment through these ML derived metrics. Apart from that, we can also use advanced techniques such as generative AI to analyze all of the different logs that get collected. And then debugging can be as simple as just starting a conversation with an AI to ask questions like, did the server process video frames correctly for this call? Did participant X receive the audio in this call? And then you can even come up with various theories for what might have gone wrong in the call and check them with an AI. So we feel that the future in this space is like really exciting, and I can't wait to see how we will tackle all of these challenges in the future. So now that all of you know about the entire observability space, I'm sure that when building RTC applications, you will prioritize this area highly, same as we prioritize media quality and other features. Please feel free to reach out to us if you have any questions for us, and thanks so much for joining us on this journey. Thank you.